Hey guys, it's Miss Cuban here. In this lesson, we're going to talk about how to classify different types of triangles. Previously, you learned that there were 6 different types of quadrilaterals, and you had to know the relationship between each one and the characteristics of a square, a rectangle, a kite. Well, now you are learning a similar thing, but this time with triangles. There are 6 types of triangles, okay? 6 types of triangles. But we have it in 2 categories. The first category, we name triangles based on their angles. And the second category, we name the triangles based on their sides. And that's a good way to remember the different types of triangles. Okay? So, for instance, let's start naming based on their angles. We know that there are 3 types of angles. Well, there's actually 4. You got an acute angle, you got obtuse, a right, and a straight. But if we ask ourselves, does a straight angle make a triangle? No, it can't even work, okay? Because if you put it together, it just does not make a triangle. So, we have an acute, okay, an acute triangle. That's where all the angles are acute, okay. They're all small. If you look at every single angle, it's less than 90 degrees. That is an acute triangle. Then you have the middle angle, which is a right angle. So a right triangle is a triangle that has a 90-degree angle. The last triangle named after its angles is an obtuse. An obtuse. It's where you have an obtuse angle and you have an obtuse triangle. Okay? Those are the 3 triangles named based on angles. Now we need to talk about sides, okay? One of them, you can have a triangle that has all the sides are equal. We call that an equilateral. Equilateral. Okay, that's where all the sides are the same length. I hope that looks the same. Is that the same? No. Let me try again. I think that's kind of the same. Okay. All the side lengths are the same. They're all congruent. They're all equal to each other. So if one side length is 3, that means all of them are 3. That's an equilateral triangle. You can also have a triangle with 2 side lengths that are the same, and we call that an isosceles. Isosceles, okay? It's where the 2 side lengths are the same. Not all of them, but 2 of them are. If one was 2, the other's 2, this could be, 3 at the bottom, or we'll say that's 3, 3, and 2. That actually looks about right. Okay, 2 side lengths are the same, the third one is different. That's isosceles. So we're going from 3 sides the same, 2 sides are the same. The other option is no sides are the same. Okay, and that is a scalene. Okay, a scalene. None of them are the same. Okay, scalene is a triangle that no sides are the same. That is how you classify the 6 different types of triangles. You need to know this information because when I ask you for area or perimeter of an isosceles triangle, or especially perimeter, I don't have to give you all the side lengths. All I have to give you is one side length, and you have to know what the others are. Okay? You have to know this. You need to put the measurements together. Okay? That is how we name the triangles and how we classify them. Okay? what you also need to know is on an equilateral triangle, if the side lengths are the same, all the angles are the same. On an isosceles triangle, if two side lengths are the same, then the two angles opposite of each other are the same. Okay? Scaling, none of them are the same. That's a good way to also know when you're trying to find the missing angle, which we're about to do now. So we're finding the missing angle of triangles. We've already learned how to do it with quadrilaterals. Now with triangles, it's a little different because all you are doing is the same thing, it just has a different number. If we look and we put these angles together, if we tear off the corners, we would have something that would look like this, and it makes a 100-degree angle. This would be angle B, angle A, angle C, and it looks like 180 degrees. So a triangle, the sum of the measures, the sum of a triangle, the sum is equal to 180 degrees. Okay? And you need to know that when you're trying to find the missing angle. So how do I find the missing angle of a triangle? Well, I write down an equation. Measure of angle A plus measure of angle B plus measure of angle C gives me 180 degrees. Now I substitute for the variables, okay? Do I know the measurement of angle A? No, it's x, so I'm just going to leave it measure of angle A. Do I know the measure of angle B? Yes, 90 degrees. Plus, do I know the measure of angle C? Yes, 45 degrees. And 180 degrees stays the same. Now, just like we did with quadrilaterals, you add the numbers together. So, I'm going to add 90 plus 45, and that should give me 135 degrees. I don't know my measure of angle A, so I'm going to keep that. And it gives me 180 degrees. Now if I'm looking for a measure of angle A and it's being added to 135, I need to do the inverse operation of addition. The inverse operation of addition is subtraction. So measure of angle A is going to equal 180 degrees minus 135 degrees. So my answer, measure of angle A, is, well, let me do my subtraction. 180 minus 135. I get 5, 7, nope, that's 4. So my answer is 45 degrees. And that's the answer to my missing angle. Okay, it's not that very different from quadrilaterals, but now at the end of this lesson, you should have learned how to classify the 6 different types of triangles. We got, based on the angles, you got obtuse, right, and acute. And you have 3 triangles named on their sides: scalene, isosceles, and equilateral. And the big thing about the angles in the triangle, they all add up to 180 degrees. And we write an equation to find the missing angle. I hope this helps you today. Rewatch if you were confused on anything, and I hope you have a good day.